This is SpaceTime, Series 21, Episode 70. Coming up on SpaceTime, Earth's magnetic field reversals could happen faster than thought. The New Horizons spacecraft spots Ultima Thule, its next target. And a leak venting atmosphere into space sparks an emergency aboard the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that Earth's geomagnetic field polarity reversals could occur over timescales of just 2 centuries, much faster than previously thought. The findings, reported in the Proceedings of the National Academy of Sciences, are based on studies of limestone stalagmites in a Chinese cave. Earth's magnetic poles flip their polarity roughly every 280,000 years. Although, to be honest, the last occurred around 780,000 years ago, and that suggests the planet's well overdue for the next. In the last 83 million years, there have been 183 pole reversals. And previous studies based on rock solidification evidence suggest that these polarity reversals could take thousands of years. But this new study, based on paleomagnetic records between 107,000 and 91,000 years ago, has narrowed this down to just a couple of centuries. Scientists were able to develop the new chronological timescale using a more accurate magnetic analysis, which provided radiometric dating of a 1 metre high, 8 centimetre wide, candle-shaped brown and yellow stalagmite discovered in a cave in southwestern China. One of the study's authors, Professor Andrew Roberts from the Australian National University, says the stalagmite data shows that magnetic field strength decreased by about 90% when the field reversal occurred, making the Earth far more vulnerable to the sun's radiation. The Earth's magnetic field provides a shield from the direct impact of solar radiation. And even with Earth's strong magnetic field today, the planet is still susceptible to solar storms from the sun, which threaten astronauts in space, damage satellites by overloading circuits, black out communications and navigation systems, and destroy terrestrial power grids, cutting electricity supplies to wide areas. A similar event in the future will increase exposure to the sun's radiation. And because of today's technological society, that would cause trillions of dollars in damage to communications and power systems. Roberts says a magnetic field reversal would have far greater impact than solar storms.
So stalagmites are amazing things. You've been into a cave, no doubt, and you've looked up and you see drip water coming down from tubes at the top of the cave. Those are called stalactites, and the drip water drips onto the bottom of the cave. That water carries minerals that precipitate out of the solution to form a stalagmite. And that stalagmite is what we sampled for our study, and it's about 1 meter long. And we took samples right down the middle of it. And the amazing thing about the mineral content of the drip water inside these caves, I mean, if you walk through a cave system, you get dripped on all the time. And this drip water carries little soil particles from the soils above. And those soil particles, some of which are magnetic, get aligned with the Earth's magnetic field as they settle onto the stalagmite below. And then they get cemented in place as the calcium carbonate precipitates out of that solution to grow the stalagmite. And so what you get is this amazing record of the Earth's magnetic field within these stalagmites. And you can also date those individual layers from measuring with super high resolution mass spectrometers, the uranium and the thorium content. And you can measure how much of the original uranium has decayed to form the daughter thorium. And by taking the ratio, you can get the age. So from a simple cave deposit, you can get a remarkable record of how the Earth's magnetic field has changed back in time.
More than just limestone.
More than just limestone. It's an amazing thing. Now, think about it. Limestone is like, it's not chalk in this case, but some limestones are chalk. And so it's a pretty clean material. It's not very magnetic at all. So you need a super duper magnetometer to measure these things, which we've used. And the sensitivity of the uranium thorium dating is also extraordinary. So it's not easy to get records of this type. It's taken about 10 years of work to find one of these stalagmite deposits that's giving us really measurable stuff. But now we're on a roll. We're starting to get more of these things because we know what we're looking for. So it's really spectacular what you can do with these recorders.
And what has it told you about the Earth's past magnetic field reversals?
So the Earth's magnetic field, your compass right now points north, but that's not always been the way. Earth has had a magnetic field since early in the history of the planet. It goes back at least 3.5 billion years out of the 4.6 billion years of history of the planet. We don't have older rocks to sample, so it's hard to know how far it really went back. But in that time, from what we know, your compass has pointed south half the time and north half the time. So the Earth's magnetic field reverses polarity quite often. When I say quite often, on average, a couple of times a million years. It doesn't seem very much, but for Earth scientists and astronomers, we deal with big numbers. So the field is in what's called reverse polarity about half the time. So your compass will point south. And so what we studied from the stalagmite is a period of time, about a 16,000-year period of time from about 107,000 years ago to 91,000 years ago, when the Earth's magnetic field went through one of these. It wasn't a full flip. It's what we call an excursion, where it flipped and went back really quickly. And what we found out is how quickly that can happen because of these incredibly precise dates. And it turns out that it can happen within about 100 years, 150 years. And previous estimates were of the order of 3,000 years for this sort of phenomenon. So because we've got a really amazing material that can be dated precisely, we've gotten what look like the first really precise dates for how quickly these reversals can happen.
Now, normally these reversals aren't a big problem. Animals seem to have been able to cope with them quite well. They still migrate to where they need to be, and generally life is carried on as normal. But things are a little bit different now. We're in the 21st century.
That's right, Stuart. So, humans and our ancestors have been on the planet for several million years. There's been, in that time, multiple field reversals. There's no evidence that any extinctions of life have happened at these times of reversals. So as you say, nothing catastrophic. But interestingly, in the 21st century, our society has electronics that we depend on all the time. We have an electrical grid system. We have satellites in space. And the Earth's magnetic field shields us from a pretty brutal solar radiation. And when the field is strong, we're protected pretty well from radiation from the sun. When it's weak, that radiation can penetrate further. And so during a field reversal of the type that we've documented in the stalagmite, the intensity of the field drops by about 90%. So in 1859, there was a huge geomagnetic storm, as it's called. It's really a solar storm, originates in the sun.
This was the Carrington event?
Yeah, and this perturbs the Earth's magnetic field by, now I'll give you some numbers. The units are a little bit weird, don't worry about that, but the numbers are about a perturbation of the field of about 1,000 nanotesla or slightly more. Now, the total strength at our sort of latitude of the field is 40 to 50,000 nanotesla, so 40 to 50 times that perturbation. But if we shrunk the field 90%, then that sort of Carrington type event would be an everyday event and bigger. And with our modern electrical dependent society, that would be a bit of a problem because power grids get affected by the currents that get generated by these sorts of storms.
Telegraph operators across the United States railroad network, they were getting electric shocks from the event when it happened. So the problems happened even back in the 1800s, but nothing compared to what we're likely to experience today. We know about these problems, so hopefully we've got a good supply of transformers lying around the place. Probably not enough for any major event still, because transformers aren't cheap.
Spot on. Yeah, your analysis is dead right. And so, the thing is, we don't know how soon any event like this could happen, whether it would happen at all. They happen once or twice per million years for a full reversal, probably every 20 or 30,000 years for one of these excursions, which would be pretty bad for us, I'd have to say. Could imagine a whole human lifespan affected by these sorts of events. But of course, we don't know when. Carl Friedrich Gauss is a very famous name in science, came up with the Gaussian distribution, the normal distribution that we use for statistics, for measuring populations, etc. He was actually the first person who started to measure how strong the Earth's magnetic field is at an observatory point. And so he established observatories in the 1830s. And since then, the Earth's magnetic field has decayed by the order of about 10%.
Well, we have the South Atlantic anomaly now, which is getting stronger, but there have been a number of reports in recent months suggesting that we're not likely to see a polarity reversal flip anytime soon.
That's right. And so where I was getting to with the 10% decline of the field, and you're dead right about the South Atlantic magnetic anomaly growing, is that it's flux of opposite polarity field growing in the southern hemisphere, which some people would say is evidence of a growing reversal of polarity of the field. The reality is we don't know. 10% decline over the last 160 years, that could be evidence of a reversal coming, but it might not be. We just don't have a long enough time record to tell us what's going on in the future. And all I can say is I hope from a society point of view is that it doesn't happen anytime soon, because we'll be incredibly vulnerable to it.
That's Professor Andrew Roberts from the Australian National University. And this is SpaceTime. I'm Stuart Gary. NASA's New Horizons spacecraft has made its first detection of its next target, the Kuiper Belt object 2014 MU69, now more commonly referred to as Ultima Thule. The probe will make its closest approach to the frozen world in just over 4 months' time, on New Year's Day 2019. Mission managers say they were thrilled, if not a little surprised, that New Horizons telescopic long-range reconnaissance imager was able to see the small dim object, which is still over 160 million kilometres away, against the dense background of stars. Taken in mid-August and transmitted back home through NASA's Deep Space Communications network over the following days, the set of 48 images marked the team's first attempt to find Ultima with the spacecraft's own cameras. New Horizons project scientist Hal Weaver from the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, describes it as finding a needle in a haystack because the image field is extremely rich with background stars, making it difficult to detect faint objects. In these first images, Ultima appears as little more than a bump on the side of a background star that's roughly 17 times brighter. But the distant Kuiper Belt object will be getting brighter and easier to see as New Horizons gets closer. The Kuiper Belt is a distant ring of frozen worlds, comets and icy debris circling the Sun out beyond the orbit of Neptune. This first detection is important because the observations New Horizons makes of Ultima over the next 4 months will help mission managers refine the spacecraft's course towards its closest approach to Ultima, slated for 12:33 a.m. US Eastern Standard Time on the 1st of January. The fact that Ultima was exactly where mission managers expected it to be, in precisely the spot they predicted, simply using data gathered by the Hubble Space Telescope, indicates the team's got a really good handle on Ultima's orbit. The Ultima Thule flyby will be the first ever close-up exploration of a small Kuiper Belt object. It'll also be the furthest exploration of any planetary body in history, shattering the record New Horizons itself set at Pluto in July 2015 by about 1.6 billion kilometres. These images are also the most distant images from the Sun ever taken, breaking the record set by Voyager 1's pale blue dot image of the Earth taken in 1990. New Horizons set the record for the most distant image of Earth in December 2017. New Horizons principal investigator Alan Stern from the Southwest Research Institute in Boulder, Colorado, says mission managers now have Ultima Thule in their sights from much further out than once thought possible, and that will help as scientists make course corrections for the final approach. New Horizons was launched on January 19, 2006 from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket. The probe made history on July 14, 2015 when it became the first spacecraft to visit Pluto. The spacecraft also imaged Pluto's binary partner Charon and their 4 moons, Styx, Nix, Kerberos and Hydra. I'm Stuart Gary. You're listening to SpaceTime. Astronomers have determined that the NearEarth asteroid Itokawa was involved in a massive collision with another object around 1.5 billion years ago. The discovery, published in the journal Scientific Reports, highlights the threat posed by potentially hazardous asteroids. So understanding the origin and evolution of these objects will help scientists better understand the dangers they pose to Earth. Scientists examined samples collected from the asteroid by the Japanese Aerospace Exploration Agency spacecraft Hayabusa. They found that the parent body of Itokawa was formed about 4.6 billion years ago, along with the rest of the solar system. But that body was destroyed by a catastrophic collision with another asteroid about 1.5 billion years ago. The authors reached that conclusion after examining rare phosphate minerals found in the Itokawa samples. They performed secondary ion mass spectrometry analysis, looking at the radioactive decay of the uranium isotope U-238, which has a half-life of 4.47 billion years, decaying into lead-206. They also examined the radioactive decay of another uranium isotope, U-235, which has a half-life of 700 million years as it decays into lead-207. They found that the phosphate minerals crystallized during a thermal metamorphism about 4.64 billion years ago. That's what formed Itokawa's parent body. But then there was a shock metamorphism due to a catastrophic impact event with another body around 1.51 billion years ago. The mineralogy and geochemistry of the Itokawa particles suggest that it's a low iron, low metal or LL chondrite. Smaller LL chondrite meteorites are frequently found on Earth. However, the shock ages of Itokawa particles obtained for this study are different to those of other shocked LL chondrites, which are around 4.2 billion years old. So that means Itokawa had a very different evolutionary history from that of the parent body of LL chondrites. So there was the original LL chondrite asteroid dating back to around 4.46 billion years. Then there was some sort of a collision about 4.2 billion years ago which broke off a lot of chunks, some of which eventually landed on Earth. But the majority of the asteroid remained relatively intact until that was about 1.51 billion years ago when another major collision occurred which tore Itokawa off the parent body and sent it towards its near-Earth orbit. I'm Stuart Gary. This is SpaceTime. Astronomers have discovered that a population of faint satellite galaxies orbiting our own Milky Way galaxy are some of the oldest galaxies in the known universe, and far older than the Milky Way. A report in the Astrophysical Journal claims these galaxies, which include Cegu 1, Bootes 1, Tucana 2, and Ursa Major 1, are over 13 billion years old, at least 1 billion years older than our own Milky Way galaxy. And that makes them among the very first galaxies to have formed in the universe. The first atoms were formed when the universe was about 380,000 years old. These were mostly hydrogen atoms, some helium, and just a handful of lithium and beryllium, the four simplest elements on the periodic table. These atoms collected into clouds and began to gradually cool and settle into the small clumps or halos of dark matter that emerged from the Big Bang. This cooling phase, known as the cosmic dark ages, lasted around 100 million years. Eventually, the gas that had cooled inside these dark matter halos became unstable and began forming stars, and these objects became the very first galaxies to have formed. With the formation of these first galaxies, the universe burst into light, bringing the cosmic dark ages to an end. Dr. Sonak Bose from the Harvard-Smithsonian Center for Astrophysics, together with Dr. Elise Deason and Professor Carlos Frank from Durham University, identified two populations of satellite galaxies orbiting the Milky Way. The first was a very faint population consisting of the galaxies that formed during the cosmic dark ages. The second was a slightly brighter population consisting of galaxies that had formed hundreds of millions of years later, once the hydrogen that had been ionized by the intense ultraviolet radiation emitted by the first stars was able to cool into more massive dark matter halos. The authors found their observations perfectly matched a model for galaxy formation which they had previously developed, allowing them to infer the formation times for the satellite galaxies. Frank says, finding some of the very first galaxies to have formed in the universe orbiting the Milky Way's own backyard is the astronomical equivalent of finding the remains of the first humans that inhabited the Earth. The findings support the current lambda cold dark matter model for the evolution of the universe, in which the yet-to-be-identified elementary particles that make up dark matter drive cosmic evolution. The intense ultraviolet radiation emitted by these first galaxies destroyed the remaining hydrogen atoms by ionizing them, knocking out their electrons, making it difficult for this gas to cool to form new stars. So the process of galaxy formation ground to a halt, and no new galaxies were able to form for the next billion years or so. Eventually, the halos of dark matter became so massive that even the ionized gas was able to cool. Galaxy formation then resumed, culminating in the formation of spectacular bright galaxies like our own Milky Way. The other interesting side to this story is that a decade ago, these faintest galaxies in the vicinity of the Milky Way would have gone totally unnoticed, completely under the radar. But with the increasing sensitivity of astronomical instruments, this new treasure trove of tiny faint galaxies have come to light in our own celestial backyard, allowing scientists to test new theoretical models of cosmological evolution. You're listening to SpaceTime. I'm Stuart Gary. There's been an emergency aboard the International Space Station, with atmosphere venting into space through a leak in the orbiting outpost. Mission managers detected the drop in air pressure while the Expedition 56-57 crew were asleep. However, because it was a slow leak, the situation wasn't considered serious or life-threatening, so the decision was made to allow the crew, consisting of 3 Americans, 2 Russians and a German astronaut, to continue sleeping. Instead, they were told of the problem after they had awoken. The crew then began the laborious task of disconnecting pipes and cables and closing hatches between the numerous segments of the space station to try and isolate the location of the leak. Eventually, they traced it to at least 2 holes, about 2 millimeters wide, in the orbital crew module of the Soyuz MS-09 spacecraft, which was docked to the Russian Vazet module. Cosmonauts stuck some duct tape across the holes as a temporary measure before grabbing some special sealant to fix the problem. The orbital crew module is part of the Soyuz spacecraft, providing some extra room, facilities and storage areas for the crew as they fly out towards the space station. The Soyuz MS-9 arrived on station in June. This orbital module will leave when the Soyuz leaves, but it's undocked and burns up in Earth's atmosphere before the Soyuz crew module undertakes its descent back to the ground. That's slated to take place in December. Mission managers say the microfracture was likely created by either a micrometeoroid or space junk impact. I'm Stuart Gary. This is SpaceTime. Astronomers are on the hunt for a meteorite which may have crashed to Earth in Western Australia. The spectacular fireball lit up the night skies to the east of Perth, followed by a thunderous boom. Dashcams and security cameras captured the meteor as it streaked across the evening skies. The Perth Observatory was inundated with calls and videos from members of the public. The director of the Desert Fireball Network, Professor Phil Bland from Curtin University, says the meteor may have crashed to the ground about 100 kilometres east of the state capital. Only about 2 to 3% of meteors survive their journey through the atmosphere, making it all the way to the ground, where they become meteorites. If it did make it to the ground, this one's thought to have come down somewhere in the Avon Valley, not far from Northam. The Desert Fireball Network monitors meteors entering the atmosphere above outback Australia, trying to trace those that reach the ground. This is SpaceTime. I'm Stuart Gary. And time now for a brief look at some of the other stories making news in science this week with the Science Report. 3 new strains of superbugs that are resistant to antibiotics and which have been spreading globally have now been detected in Australian hospitals. A report in the journal Nature Microbiology claims the bacteria called Staphylococcus epidermidis are, as their name suggests, widely found on human skin. But these new strains are resistant to almost all antibiotics, and some of the strains found in Europe are resistant to all known antibiotics. Scientists are concerned that hospital practices, including the use of antibiotic-impregnated medical devices such as catheters, may have driven the evolution of this once benign bacteria towards potentially incurable infections. A new study has found that people with autism suffer far higher rates of depression. The findings, reported in the Journal of the American Medical Association, are based on extensive decade-long studies of both kids and young adults in Stockholm. Researchers found that by the age of 27, some 20% of people with autism spectrum disorder had a diagnosis of depression compared with just 6% of the general population. Scientists found depression was especially prevalent for those with autism spectrum disorder who didn't have intellectual disabilities. And the higher risk couldn't be explained by familial links to depression. A new study warns that future El Niño and La Niña events will amplify changes to temperature, precipitation, and the fire risk caused by climate change. The findings, reported in the journal Geophysical Research Letters, are based on the latest climate models. Scientists created computer climate simulation models spanning the 20th and 21st centuries, finding that in a business-as-usual scenario, the one we're most likely going to find ourselves in, temperature extremes are likely to occur mainly over land regions, and independent of changes in Eastern Pacific Sea surface temperature variability. A new study warns that Iran's online political influence has now grown to global proportions. The Islamic Republic has been using social media accounts and fake websites to spread propaganda in 11 different languages. Studies by groups including Reuters and Facebook have identified hundreds of accounts which are part of an Iranian government project to covertly influence public opinion in other countries. These accounts are spread across dozens of social media sites, including Facebook, Instagram, Tumblr, Twitter and YouTube. Cybersecurity firms FireEye and ClearSky have both independently confirmed the findings, adding that a web of sites and social media accounts known as the International Union of Virtual Media, or IUVM, is also part of Tehran's campaign. The sole purpose of the International Union of Virtual Media is to push content from Iranian state media and other outlets aligned with the government in Tehran across the internet, often obscuring the original source of the information, such as Iran's TV Press, the Fars news agency, and Al-Manor TV, which is run by the Iranian-backed terrorist organization Hezbollah. Qatar and Singapore have topped the list with the world's fastest internet download speeds, according to Speedtest's latest global index. The findings show that Singaporeans have fixed broadband download internet speeds of 181.47 megabits per second, while Qatar tops the mobile list with 62.63. The US was in 6th place globally, with average fixed broadband download speeds of 96.91 megabits per second, but only 48th worldwide with mobile speeds of around 27.4. At the other end of the scale is Tajikistan, with average mobile speeds of 5.02 megabits per second, and Algeria, with average fixed broadband speeds of 3.68 megabits. As for the Land of Oz, well, Australia is well down the list in 53rd position, with fixed broadband speeds of just 31.53 megabits per second, and mobile speeds of 52.26. But it would appear things are not always equal. For instance, I've just checked my own Telstra ADSL2 download speed, and it's currently running at just 13.2 megabytes per second. And while that's well behind best practice both locally and internationally, it's apparently still fast enough to keep the nation's biggest telco in first place for download speeds, at least according to some measurements. To explain, here's Alex Zaharov-Reutt from IT Wire.
Telstra is the AT&T of Australia. It's the biggest, I call it the 800-pound telco gorilla as opposed to the 800-pound gorilla. They're the biggest telco. And look, they've come out on top in one test and in number 5 spot in another. The top test was with the Ookla speedtest.net. People might know the speedtest.net website and app. It's the one I use to check the speed of my various connections. Yeah, it's very, very good. Here. And in that particular test, they came out as the number one. They won the 2018 Speed Test Award for the fastest mobile and fixed network provider. But in another test by the Australian Competition and Consumer Commission, it was shown to be a laggard. You know, it was in 5th place behind some of its competitors, TPG, iiNet, Optus, and there's also a company called MyRepublic. So, look, obviously these tests are done in different ways. I mean, it is well known that Telstra is the biggest provider with the best network in Australia. But obviously it depends how you structure your tests and how the test is done to determine how fast your particular network is. But in Australia, we have the National Broadband Network, a scheme that's designed to give everybody super fast speeds. And it's been a bit of a dog's breakfast in its rollout. It was meant to be fibre to the premises everywhere, but it ended up being a mishmash of hybrid fibre coaxial, fibre to the node using copper cables, fibre to the distribution point, or fibre to the curb as it's called, where instead of to a box that's like a bar fridge on the end of your street, they bring it right to your curb, and then they use copper for the last mile. And also wired, fixed wireless and satellite wireless. And so we have this mishmash of connectivity that delivers different speeds and causes different problems for different people.
Are there reports that Telstra are deliberately slowing down their internet speeds if that area is about to swap over to the NBN?
Well, I can explain why that's supposed to be happening. When the NBN is put into place, and this is where you've got fibre to the node, over the copper wires, so you've got the bar fridge at the end of the street. When you've got a combination of ADSL and then effectively what is VDSL, which is a faster form of ADSL, the two services cannot coexist very well. So they need to slow down the speed of the ADSL and the VDSL to allow both of them to coexist. After 18 months, ADSL will be switched off, and then the VDSL, the fibre to the node, can be set to full speed, and so speeds will increase. But if Australia had chosen a fibre to the premises directly into everybody's homes, it would have been obviously a lot more expensive to do that, but you wouldn't have had these problems where you've got multiple competing technologies on the same network and causing crosstalk and slowdowns. And unfortunately, that's the path we're on. And that report by Alex Zaharov-Reutt from IT Wire. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.